Welcome to This Explainer. Today, we're completely shattering the illusion of a serene, peaceful night sky, and we're uncovering the violent, dynamically shifting arena that is our universe. We look up and tend to imagine space as this static, quiet painting, but we're acting as cosmic detectives today. We're going to dig into some truly fascinating new data to piece together a hidden history of cosmic collisions, missing galaxies, and the unbelievable forces that literally built the cosmos we live in. So let's jump right in by asking a question that, honestly, sounds a little terrifying. Is our very own Milky Way an active predator? Does it harbor this dark, ongoing history of consuming its neighbors? Now, I know that sounds straight out of science fiction, but it's a very real question astronomers are asking right now. We've known for a while that the early universe was incredibly chaotic, just cosmic detritus clumping together. But the big question we're looking at is, has our cosmic home continued to grow by forcefully devouring the smaller galaxies around it? To really understand this cosmic crime scene, we first need to lock down our main concept, galactic cannibalism. It's exactly what it sounds like. It is the literal consumption and absorption of smaller galaxies by much larger ones. Basically, when a massive host, like the Milky Way, has these smaller satellite dwarf galaxies orbiting it, its immense gravitational pull doesn't just, politely hold them in place. No, it actively tears them apart. It strips away their stars over billions of years and eventually just completely absorbs them. And the weapon of choice here? It's gravity, operating through a really cool mechanism called dynamical friction. Picture a smaller galaxy plowing through a massive sea of dark matter and stars. As it moves, it actually creates a gravitational wake right behind it. And that wake acts like a massive drag force. It decelerates the smaller satellite galaxy, causing its orbit to decay. So as it slowly spirals inward, the larger host galaxy's tidal forces just aggressively start stripping away the outer layers. Eventually, all that's left is a dense core, which merges right into the host center. Now, obviously, astronomers can't just sit and watch a billion-year collision happen in real time, so they have to look for the forensic clues left behind. They track what we call stellar streams. These are these long, incredibly thin trails of ripped-away stars that can encircle a host galaxy for eons. They also hunt for highly eccentric, metal-rich rogue stars that totally defy the galaxy's normal rotation. And, incredibly, they even look for literal wrinkles in the galaxy's phase space. These are basically gravitational ripples left over from past collisions. Turning our investigation inward, it is time to look at the Milky Way's very own rap sheet, because, as it turns out, our cosmic home is quite literally built on the remains of the dead. Seriously, when you look up at the night sky, you are often looking at stolen goods. Just take the Sagittarius dwarf galaxy as an example. It's a victim that is currently in the process of being shredded, leaving this massive trail of stars wrapped entirely around us right now. Then there's Omega Centauri. For the longest time, we thought it was just a massive star cluster, but new evidence actually points to it being the stripped, naked core of an ancient dwarf galaxy that we completely devoured. We even have what are called splash populations. Those are scattered, metal-rich stars that were literally kicked into these wild, eccentric orbits from those violent past collisions. For a really long time, we kind of thought our galaxy had just settled down. The old consensus was that the Milky Way's last major collision, which astronomers call the Gaia Sausage Enceladus merger, happened a massive 8 to 11 billion years ago. But, science is always self-correcting. High-precision data from the Gaia Space Telescope recently tracked the exact positions and velocities of millions of stars, and it proved that our galaxy's last major collision actually wasn't ancient history at all. The evidence now points to an event called the Virgo radial merger, and it happened surprisingly recently. And the crucial piece of evidence boils down to this time frame, 1 to 3 billion years. See, by measuring how those gravitational wrinkles I mentioned earlier dissipate over time, astronomers realized something crazy. They haven't had enough time to smooth out yet. If that merger happened 8 billion years ago, those wrinkles would be completely mixed and gone by now. But because they are still clearly defined, this Virgo radial merger had to have happened a mere 1 to 3 billion years ago. It absolutely rewrites our galaxy's entire timeline. But hey, we aren't the only predators in our local cosmic neighborhood. Let's look at our massive neighbor, the Andromeda Galaxy. Because it turns out, Andromeda has an even more violent past than we do. Andromeda's history is literally written in its sprawling debris. It features this thing called the Giant Southern Stream, which is a massive trail of wreckage from a chemically rich dwarf galaxy that it totally devoured. In fact, recent studies show that Andromeda's inner halo is almost entirely dominated by a single massive immigration event.
It likely experienced what we call a major wet merger, basically a collision involving tons and tons of gas, within the last 2 to 4 billion years. So its history is remarkably similar to ours, proving that this kind of aggressive growth is just standard operating procedure in the universe.
Now, to understand the true scale of galactic cannibalism, we really need to look back to the early universe. We want to see how these collisions shaped the very first massive structures out there. Was this violent process happening back when the universe was just a tiny fraction of its current age? Well, thanks to the James Webb Space Telescope, we are literally catching early galaxies red-handed. JWST has peered way back to when the universe was less than 1 billion years old, and it found massive systems already engaged in cannibalism. Take the ancient PJ30821 quasar system, for example. It is already incredibly massive, and JWST caught it aggressively devouring 2 distinct, massive companion satellite galaxies. This actually explains a huge mystery: how early supermassive black holes grew so huge so fast. They were just being constantly fed by these galactic mergers. But that makes you wonder, what happens to the absolute monsters at the center of these galaxies? When 2 galaxies merge, their central supermassive black holes basically sink to the core of the newly formed galaxy. That's driven by that exact same dynamical friction we talked about earlier. So as they get closer and closer together, they form a binary system, and they start emitting just massive amounts of gravitational waves. That process slowly bleeds away their orbital energy until they finally coalesce into a single, unbelievably massive black hole. Okay, so the crucial point here is understanding the aftermath of these incredibly violent events. For decades, astronomers relied on this theory known as the merger-quasar-quench paradigm. The idea went like this. When galaxies collide, huge amounts of gas fall into the newly formed supermassive black hole. That triggers a blindingly bright quasar, and this quasar would supposedly release so much intense energy that it just blasted away all the remaining gas in the galaxy, instantly quenching it and permanently killing its ability to form any new stars. But there's a huge plot twist. A shocking new study from Florida International University just completely threw a wrench in that idea. They analyzed over 11,000 simulated galaxies using this highly advanced cosmological simulation. Now, if mergers killed galaxies, you would expect to see star formations stop shortly after those collisions, right? But they found that a mere 3% of major mergers were actually followed by star formation shutting down within 1 billion years. 3%! Furthermore, only about 12% of all quenching events across the board were associated with mergers at all.
This data totally shatters that long-held paradigm. And as the lead author, Camilo Casimiro, pointed out, the willingness to test even widely accepted ideas against new data is really the absolute bedrock of science. So the reality here is that galactic cannibalism doesn't automatically mean the sudden, spectacular death of a galaxy. Instead, galaxies usually survive the collision. They just keep on forming stars, which heavily suggests that much slower, quieter internal processes are what eventually put a galaxy to rest. So looking to our own future, well, we have a pretty massive collision on the horizon ourselves. In about 4.5 billion years, the Milky Way and Andromeda are inevitably going to collide. But here's the truly amazing part about it. Because the physical space between stars is just so unfathomably vast, direct stellar collisions will actually be incredibly rare. Like literally, our solar system wouldn't even feel a thing. Instead, the gas clouds of the 2 galaxies will compress together, which will trigger this massive, brilliant burst of new star formation. Our 2 supermassive black holes will eventually spiral in and merge, and gravity will ultimately reshape our 2 beautiful, distinct spiral galaxies into a single, giant elliptical galaxy. Which leaves us with a final, kind of provocative thought to ponder today. When our 2 great galaxies finally merge into a single cosmic giant billions of years from now, and all those brilliant starbursts finally fade away, what forensic clues will actually remain? Will some future observer, maybe standing on a planet born from the ashes of our collision, ever be able to trace the violent, cannibalistic history of exactly how their home came to be? Keep looking up and keep questioning what you see.